Hello, welcome to Abington Heights Comet News Station. I'm Liz Durden.
And I'm Raghu Nagori. This episode of CNS is solely dedicated to the atom.
Atomic theory first originated with Democritus, an ancient Greek, who was first credited with coming up with the atom.
He said if you keep breaking something down, it would get to a size that can no longer be broken down.
This is where the word atom comes from, the Greek word atomos, meaning indivisible, or not to be cut.
He knew that atoms were small hard particles that consisted of the same material but were different in shapes and sizes.
He also said that atoms were infinite in number, that were always moving, and capable of joining together. Now let's look at the next model proposed by the scientist, Dalton.
He said that stuff can be broken down into elements, and elements are atoms with different masses. Dalton said that compounds are a combination of elements.
Dalton just essentially expanded on Democritus' idea of the atom. At the conclusion of his analysis, he stated that atoms make up all matter, atoms can't be broken, atoms of a given element are identical, compounds are a combination of different kinds of atoms, a chemical reaction is a rearrangement of atoms, and atoms can neither be created nor destroyed.
This idea is popularly described as the billiard bar. Now let's look at Thomson's version of the atom. Thomson's experimented with cathode rays. They are essentially beams of electrons.
By having the beam interact with the electric and magnetic fields, Thomson was able to determine the mass to charge ratio for an electron.
So from that he knew that the electron came from the atom. It had a negative charge and a small mass. Thomson took the idea of the atom and tried to incorporate the evidence for the electron. His theory is commonly called the plum pudding model because the electrons are like things in positive pudding.
He proves that the atom was not indivisible because it was of smaller pieces, electrons and protons.
Let's dive into the next model, Rutherford's model. Rutherford shot some alpha particles at some really thin gold foil. Some of the positively charged particles moved through the foil, some of them bounced back. Therefore, if an electron was small and negative, then the atom must have small positive nucleus with the electrons around them.
Let's look at Bohr's model. The model is in a lot of introductory science textbooks. The model tries to make a connection between light and atoms.
Through his experiment, he conducted that the colors of light correspond to different energy levels, the electron.
And this is needed to understand the Bohr model. Electrons can only be at certain energy levels within the atom.
This theory is like a planet orbiting the sun, but an electron cannot orbit.
The Bohr model depends on a connection between the frequency of light and the energy of the level change. If the light of a frequency corresponding to the energy change interacts with the atom, the energy can absorb the light and jump up a level. If an excited electron jumps down a level, it loses energy. The energy that the electron loses becomes light with the frequency corresponding to a change in energy.
He states that electrons are small negatively charged, protons are in the nucleus, which is small compared to the size of the atom. For a particular element, only certain frequencies of light are absorbed or emitted. Electrons with low energy would orbit closer to the nucleus, while electrons with high energy orbit further from the nucleus.
Last, but certainly not least, is the Schrodinger's and Heisenberg model, which is also called the electric cloud model, and the one used today.
The Bohr model is no longer accepted because the electrons are still thought to orbit the nucleus, just like planets orbit the sun, but the electrons follow quantum physics.
His quantum mechanical model created equations to describe what the electrons would do in a hydrogen atom. The four quantum numbers used in the equations are n, l, m sub l, and m sub s.
His theory describes atomic orbitals, which are regions of space where there is a high probability of finding an electron. An s orbital is a spherical shaped, a p orbital is a dumbbell shaped, and a d orbital is a clover shaped.
This concludes our segment on CNS. Again, I'm Liz Durden.
And I'm Raghu Nagori. See you next time.